Hi guys, today's topic is trigonometric equation. Trigonometric equation. The most basic form is sine x goes to b, for example, half. And then we should have the range of x, right? Then how to solve this? We already know that sine is positive on quadrant 1 and quadrant 2, right? In Q1, the sine is half, the angle is pi over 6. We know this. Then we should have the same angle on Q2 so that we can read the answer like pi over 6 and 5 pi over 6. Why? Yeah, the terminal for this one, this terminus, the radian goes to be 5 pi over 6, right? This is the most basic form. Of course, yeah, we can have cosine x to be negative square root 3 over 2. And then x is in one revolution. Then cosine is negative in Q2 and Q3. So we draw a triangle like this, and then this much is again pi over 6. So the first terminal is 5 pi over 6. Why? Yeah, we subtract pi over 6 from pi, right? And then the second one is 7 pi over 6. So the x goes to be 5 pi over 6 and then 7 pi over 6. This is the most basic form. The common factor for those questions is, okay, the values are from the special triangle like 30, 45, 60 in radian, pi over 6, pi over 4, and pi over 3 of those. If the angle is different, then how? For example, sine x goes to be negative 0.2. Oh yeah, we should do the positive one first. And then x is in single evolution. Then how we can solve that? Again, sine is positive. Those angles are in Q1 and Q2. So that we can draw two triangles like this. And then we can calculate this angle by inverse geometric function. We call this as a reference angle. Usually we use the letter alpha, and reference angle is acute angle, which means always alpha is in 0 and pi over 2. Then how we can calculate this alpha? That is sine inverse 0.2, right? Then this much angle is also the same. Yeah, this much angle is sine inverse 0.2, right? Then, hello, why is it like that? Yeah, okay, reconnected. Sine inverse 0.2. And then here the radian is pi, so that we can read this terminal like pi minus sine inverse 0.2, right? So the x goes to the answer goes to sine inverse 0.2 and pi minus oops and pi minus sine inverse 0.2. Yeah, those two are the answers. Am I right? Then again, okay, let's do the cosine goes to be negative 0.6. Again, the range of x is still in between one revolution. Now we have cosine is negative, so that the angle must be in Q2 and Q3, right? But we can calculate our reference angle. This is cosine inverse 0.6. This much angle must be in Q2 and Q3. Those angles are the same. So we can read this terminal to be pi minus cosine inverse 0.6. Then this terminal to be pi plus cosine inverse 0.6. So those two angles, the answers. Okay, the first one is pi minus cosine inverse 0.6. The other one is pi plus cosine inverse 0.6. Those two are the answers. Yeah, up to here is the most basic thing. Then, okay, we move to the a little bit advanced course. For example, sine 2x goes to be what 0.1, and then x is in between 0 to 2 pi. And how we can calculate the answer? First, we consider 2x as our big block. So we consider the question like sine u to be 0.1. Then what we have done before, okay, we had the range of u from the question, right? So that we need to calculate the 2x range. That's from 0 to 4 pi, which is 2 revolutions. And then we go for the unit circle xy diagram. Our reference angle alpha is again sine inverse 0.1. Then that is in Q1 and Q4. Y sign is positive, right? So that no Q1 and Q2, sorry. So this much angle is actually alpha, and then this much angle is also alpha. So that we can read this as sine inverse 0.1. Then this one is pi minus sine inverse 0.1, right? So the answer goes 2x goes to within 2 revolution, which means 1 revolution and then another one more revolution. Yeah, we have 1, 2, 3, 4 answers. The first one is sine inverse 0.1. The second one is pi minus sine inverse 0.1. The third one, this is the third one, right? Third one is after 1 revolution we have, yeah, the the circular, the spiral shape is meeting with the sine inverse 0.1 again, right? So that we need to add 2 pi from this one. And then again we need to add another 2 pi to this one, so which is 3 pi minus sine inverse 0.1. And then your left hand side was 2x, still it's not the x, right? So that x goes to be half sine inverse 0.1, half pi minus sine inverse 0.1, and then half 2 pi plus sine inverse 0.1, and the last one is half 3 pi minus sine inverse 0.1. Those 4 are the answers. Of course, yeah, you can calculate by your calculator to get the get in decimal number, right? Understand? Is it doable, right? Okay, let's go for one more example. Now let's say tangent 3x goes to be negative 0.3, and then x is, now the range is a bit more complicated, negative pi to pi. And how we can solve this? The first thing we should do is, okay, the range for 3x, the alpha is tangent inverse 0.3. Then we draw the xy plane. Tangent is negative, which is in Q2 and Q4, right? This much is alpha, this much is alpha. So that 3x goes to be, first we move from 0 to 3 pi like this. So we have the first one, we have the second one, we have the third one, right? The first one is pi minus alpha. Second one, 2 pi minus alpha. The third one, 3 pi minus alpha, right? But it should rotate up to the negative 3 pi in opposite direction, right? Which means from here, opposite direction, this is negative 2 pi, so that up to the negative 3 pi here. So this is the first one, This is the second one. This is the third one. The first one is negative alpha. And then the second one is pi, negative pi minus alpha. The third one is negative 2 pi minus alpha. So we have 1, 2, 3, 4, 5, 6. Of course, again, we need to calculate x goes to be 1 over 3 pi minus alpha, 1 over 3, 2 pi minus alpha, 1 over 3, 3 pi minus alpha, 1 over 3 minus alpha, 1 over 3 minus pi minus alpha, 1 over 3 minus 2 pi minus alpha. Yeah, those 6 angles are our solution. So up to here is so-called the trigonometric equation solving. In summary, you can say that sine x goes to be something, cosine x goes to be something, tangent x goes to be something. Yeah, we have solved those kind of things. And then this x can be 2x, 3x, or sometimes x plus pi over 4 or whatever. Yeah, those kind of variations are there. So the first thing you should do is, okay, check the range of the domain. You can say just domain, which is inside the sign, right? This one. Yeah, we should check that range. We should convert the range of this part. Second, we can calculate what? Reference angle. Today, what I didn't use is the calculator, but yeah, you can calculate the reference angle by your calculator, and then you can convert that into the decimal. Yeah, from the beginning, that is also possible. Anyway, you should calculate the reference angle, and then that is, I said, that is positive value, right? Then acute angle. Then the third one, okay, we go for the XY plane. Or you can just imagine this is like a unicircle. Check the quadrant. Q1, Q2, blah, blah, Q4. Depending on what? Depending on this value, right hand side and left hand right hand side value, whether that is positive or negative. Yeah, sometimes it can be Q1 and Q2 if sine is positive. If sometimes there can be Q1 and Q4 if cosine is positive, something like that. You can check that and then draw it. Draw terminal on that quadrant. After that, so-called domain in this part. By considering the range of those domain, yeah, check, get the answer. Get the values. Then, yeah, today my notebook condition is really bad. I don't know why it's in like this. Yeah, I believe, yeah, still, yeah, everything is going on. It's still connected. Okay, write the answer in terms of just x. You can convert 2x into the x. You can convert, okay, for example, x plus pi or more into the x, whatever. This is the sequence, right? You can defer the previous my examples. But the next example is something like this one. Sine x squared minus sine x minus 2 goes to be 0. I say this is not this is not the trigonometric equation, you know. This is actually the quadratic form of the trigonometric functions, right? Trigonometric expressions. So we need to convert this into the trigonometric equation first. After that, we just apply the previous theory to solve that. At the very beginning, okay, we found that this is quadratic expression of the quadratic equation of the sine x, right? So that we consider this as a u squared minus u minus 2 goes to be 0. Then we can factor this so that u goes to be 2 and u goes to be minus 1, something like this, right? We can apply the same thing here. Then this one goes to be sine x minus 2, sine x plus 1 goes to be 0. Then, okay, sine x minus 2 is 0 or sine x plus 1 is 0, which means sine x is 2 or sine x is minus 1, right? Yeah. Then, then we can reject this. Why? How come we can reject this? Because sine x must be, oh my god, I'm so sorry for this disconnecting, so frequent disconnecting. Today is like this so many times. Sine x must be within minus and 1, so that sine x cannot be 2, so that we reject this. And then sine x is negative 1. And then let's say if x is within one revolution, then we can say that x is 3 pi over, is it? 3 pi over 2. So that this is the only one answer. So the second type of trigonometric equation is you need to factorize, even though sometimes that is not really simple like this, you know. Sometimes there is a sine 2x cosine 2x together with the sine x and cosine x. In that case, what you need to do is you need to apply the trigo identity formulas. After that, you should go for the factorization. No other way. Okay. So if there is sine 2x, sine x together, or cosine 2x, cosine x together, or all of them together, then you must go for the factorization. That's the first way to solve that. Okay. But there are some special cases, like okay, sine x minus square root 3 cosine x goes to be 0. And just for make this question to be simple, I use the range to be just one revolution. How to solve this? It's not a quadratic form, but we have sine and cosine together, right? What we can do is the right hand side is 0. We are focusing on that. Your right hand side is 0. That's why how we do is sine x goes to be square root 3 cosine x. Then we bring this cosine to the left hand side. Then sine x over cosine x goes to be square root 3. Then it turns to be tangent x is square root of 3. Then this is trigonometric equation with no, right? Yeah, this one is easy. Then the rest I don't do. But if your right hand side is 1, then how? We cannot bring the cosine x to the right hand side because, even though we bring this to the right hand side, we cannot divide by cosine x everywhere in order to make tangent x to be something, right? This method is not working. Left hand side method is not applicable to the right hand side question because of this just one, right? Then how we do? We have our formula. Some textbooks say this is a R alpha formula or whatever. Anyway, what we know is sine x minus square root 3 cosine x goes to be, let's say we use sine x minus cosine is 1 sine square root 3 cosine tangent minus pi over 3. How do I calculate? Tangent inverse square root 3 over 1 is pi over 3, right? And then 1 times, oh yeah, in front here I need to have 2, sorry. 1 times sine x minus square root 3 cosine x can be converted like half sine x minus square root 3 over 2 cosine x, and then 2 we have, and then 2 times sine x cosine pi over 3 minus cosine x square root 3 over 2, no, this is sine pi over 3, and then sine cosine minus cosine sine, there is sine x minus pi over 3. Right? This is just for your reference. So I can say everything this much is your reference. So that the next step here we can go is 2 times sine of x minus pi over 3 goes to be 1. That's why sine of x minus pi over 3 goes to be 1 over 2. Oh, this is the same form with the previous trigonometry equation. And then x is from 0 to 2 pi. This is the full set. So that we can convert the range x minus pi over 3 here, and then draw the xy plane, and then check where is the half, and then within the range we can get the solution. Something like that, right? So this is the first variation. Another thing is, if sine a, oh, the question is something like this: sine 2x is sine of 3x in, let's say, between pi 2 pi, okay, 2 pi. Then how we can solve this? This is totally different question. Why? We have different angles inside the sine, right? That's the most difficulty. Previously here, yeah, even we have sine and cosine, we have the same angle, x and x, x and x, right? But now that is different. The sine goes to be sine. How we solve that? Sine is the same with sine. What is the possible situation? Let's say instead of 2x and 3x, I just say that, okay, a and b here. Sine is same with sine. A and B can be in the same terminal, right? So-called the coterminal angles. How we can express the coterminal angle? Once we subtract A minus B, then there's 2 pi. See? 30, 390. Once we subtract them, there is 360, right? Instead of 390, negative 330, once we subtract, there is again 360, or so whatever. So if those two angles are coterminal angles, sine A is same with sine B, right? Another case is, okay, A is here, B is here. As long as this much angle and this much angle is the same, then yeah, the sine values are the same, right? In this case, once we add those two angles, it will go for this side. which is odd pi, which I can write 2k plus 1 pi. No, it's not 2 pi and 2k pi. I call this as an even pi. So that a plus b goes to be 2k plus 1 pi. Okay? So go back to the original question. Sine of 2x is sine of 3x. Then x is in one revolution. Then how we solve that? The first, okay, 3x minus 2x goes to be 2k pi. And then another case is 3x plus 2x goes to be 2k plus 1 pi. Of course, k is integer. Then x is 2k pi within one revolution from 0 to 2 pi, so that x goes to be 0 pi and 2 pi. And then from the bottom case, 5x goes to be 2k plus 1 pi, so that x goes to be 5 2k plus 1 pi. X needs to be within 0 to 2 pi. When k is 0, yeah, x can be pi over 5. If k is 1, there's pi, right? Is it? Oh no, 3 pi over 5, sorry. And then 5 pi over 5, 7 pi over 5, 9 pi over 5. Up to here, the answer this is pi. So by combining those two, x can be 0 pi over 5, 3 pi over 5, pi, 7 pi over 5, 9 pi over 5, and then again 2 pi is also the answer. Those are the answers. Understand? Today my computer is not really nice. So many disconnection and then they connected, something like that. Then how about cosine goes to be cosine? That's too big. Cosine goes to be cosine b. How? Cosine can be the same. Cosine, of course, again, both are the same. The coterminal so that we can say 2k pi. And the another case can be one is here and the other one is on the bottom, right? Those two angle magnitude is the same. So in this case, once we add those two, then it goes to be even pi. Okay. Again, the same question I can solve. For example, cosine 2x goes to be cosine 3x from 0 to 2 pi. Then first case, okay, 3x minus 2x goes to be 2k pi, so that x goes to be 2k pi. Oops, I did one thing wrong here. Yeah, pi we don't have, right? Yes, correct. But still we have pi here, so that the answer is correct. Anyway, so that x goes to be 0 and 2 pi only. Second case, 3x plus 2x goes to be now 2k pi, so that x goes to be 5 and 2k pi, so x goes to be 0, 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5, and then 2 pi. So by combining those two, x is 0, 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5, and then 2 pi. Yeah, those are the answers. See, for example, if we take the 4 pi over 5 here, take the left hand side, cosine 2 times 4 pi over 5 goes to be cosine 8 pi over 5. And then cosine 3 times 4 pi over 5 goes to be cosine 12 pi over 5, which is same with cosine 2 pi over 5, right? 8 pi over 5 is where? That is here 5, 6, 7, 8, around there. So this much is 2 pi over 5. And this terminal is 8 pi over 5, right? 2 pi over 5 is here. So those two values, cosine values, are still the same, right? So yeah, confirm those are the answers. Something like that. Yeah, today what I have done is trigonometry equations. The first, I have explained about the basic form of the trigonometry equation, right? And then if the inside sign is not x, then yeah, how to do? Yeah, that one I have explained. First thing we need to do is we need to convert the range of the inside part of the sign. I call that as the domain of the sign, right? Actually, that's not the domain. Anyway, the inside part of the sign. Then the last one, okay, is kind of a complicated form of the trigonometric functions, advanced form. Yeah. The first thing, sine goes to be sine plus cosine goes to be zero case, and then another case is sine and cosine goes to be non-zero. In that case, we should use the R formula. If sine x and cosine x inside the sine and inside cosine must be the same, then we can apply what R formula to merge those two into the one sine function or the single cosine function. The last thing is if the inside value of sine and cosine is different, then how? We must rewrite this as a sine goes to be sine and cosine goes to be cosine, those kind of form, and then you can apply those concepts to solve that case, right? Okay, today I do up to here. Today we did the trigonometry equation, and today I'm so sorry. There's some of the disconnection of my OneNote during the recording, but I don't want to redo this. I just upload this to my website, to the YouTube. You just go and check that. See you next time. Bye.